Okay, so today we're going to deal with the topic of functions. This topic is a pretty straightforward topic. The questions which you will get on this topic do not vary much, okay? So let's just get right into it. This is the introduction to functions, okay? When dealing with functions, we want to discuss a few things first. We want to discuss intervals, okay? For open interval, the endpoints are not included. In this case, the endpoints are a and b, okay? For an open interval, basically the endpoints are not included. So x is between the values of a and b, and this is how we denote it if they are not included, okay? So example, if I have the interval 4 is between x, which is between 6, I would write it as 4 comma 6. Okay, no, this is not a coordinate, okay? Notice this is not a coordinate, right? What this basically means is the values of x could be between 4 and 6, but it cannot include 4 and 6, okay? For closed interval, both the endpoints are included, okay? In this case, again, if I say 4 less than or equal sign x 6, right? This means that x is between 4 and 6, and it includes the value 4 and 6, okay? And this is how we denote it. So this time here we use square brackets, okay? So square brackets represents that that value is included, whereas the regular bracket means that value is not included. And then we have a half open or half closed interval, which is where only one endpoint is included. For the first example here, the value a is included, so notice we have a square bracket here, but b is not included, so we have a regular bracket here. In the second example, as you can see, we have b being included, but e is excluded, okay? So again, if we have 4 less than or equal to x less than or equal to 6, okay, no, actually, sorry, this is a closed interval. How we write this is, since it includes the value 4, we would use the square bracket, comma 6, and we would use a regular bracket here. So what does this mean? This means that it includes the value 4, but it cannot include the value, or it does not include the value 6, okay? So that's pretty much it for intervals, okay? You have an open interval, a closed interval, or a half open interval. A half open interval is also referred to as a half closed interval, okay? Now, just we have some definitions here now. A function assigns each element in a set A to a corresponding element in another set B. Okay, just think of this as x and y values, where set A would be the x values and set y would be set B would be the y value. Okay, so a function is denoted by f of x. Okay, normally you'd normally say equation f of x is equal to x squared plus 2. Let's see, okay? That's normally how we see it denoted. Again, if we write in f of e, what this means is that wherever we see the value x, we just replace it by e. So if we write f of e, all that would be is e squared plus 2. That's all that is, right? Set A is independent and is referred to as the domain, okay? And this usually refers to all the x values, okay? So all the x values which you could possibly have, you call that the domain of a function. And set B is dependent on the value of x, okay? And this is referred to as the codomain, right? The elements in set B which have a corresponding value in the domain is called the range, okay? So you have these definitions, you're probably not exactly sure what they mean, so the best way to actually explain what they mean, okay, is by using examples, okay? Note that all elements in A must have a corresponding value in B. Elements in B, however, do not need to have a corresponding value in A. So let's just do, so you might be a little bit confused as to what that means. So the best way to clear up that confusion is with an example, okay? So this here, what this says is that A maps on, 1 maps onto the value E. So let this be set A here and let this be set B here, okay? 2 maps onto B, 3 maps onto C, and 4 maps onto D, okay? And as you can see, what it says, it assigns each element in set A. So each element, example, the number 1 is assigned to corresponding in another set B. So the element 1 is assigned to an element in B, and that element is E. Okay? And this arrow, we could refer to this as f of x here. Okay? When you apply the function, it maps it on and gives you a corresponding value in B. Okay? Now, so what is the domain? Okay, we could consider A the x values and B the y values. Okay, this here, all the values in set A, the x values, we call this the domain. Okay, this, all these values here. So if you want to write the domain here, okay, we normally use this bracket. Okay, and the domain is 1. We celebrate each element with a comma. 1, 2, 3, 4. Okay, that is the domain. The domain is all the values in set A. Okay, the codomain now refers to all the values in set B. Okay, so the codomain here is A, B, C, D. Okay, and the range refers to all the values in B which have a corresponding value in A. Okay, so the range here, in this case, the range and the codomain is the same. The range here is also A, B, C, D. Okay, and this is a function. Okay, so let's look at the next one now. We have, let the arrow represent f of x. We have our elements in A being mapped onto our elements in B. Again, the domain is all the elements in set A, which again would be your x values. So the domain in this example here, the domain is 1, 2, 3, 4. Okay. The codomain now refers to all the elements of B. Okay, which in this case would be A, B, C, D, E, F. Okay. The range now here we'll see the difference between the range and the codomain. Okay. In this case, the range is going to be a subset of the codomain. Remember, the range refers to all the elements in B which have a corresponding element in A. Notice these values, these two letters here, E and F, they have no corresponding value. They have no value in A which maps onto them. So they are not part of the range. They are part of the codomain because the codomain includes all the values in set B. Okay, but since nothing maps onto the letters E and F, they do not become part of the range. Okay, so the range in this case would only be A, B, C, D. Okay, and that is the range. So as you can see, the range is a subset of the codomain. Okay, now we have this one here now. Okay, we have 1 maps onto A, 2 maps onto B, 3 maps onto C, 4 maps onto D, and 5 maps onto nothing. Now, this here is not a function. Not a function. Why is this not a function? This is why. Because earlier up we said that all elements in A must have a corresponding value in B, right? Elements in B do not need to have a corresponding value in A, which is why you could have a codomain and a range which differ, okay? But all the elements in A must have a corresponding value in B for it to be a function. If it doesn't, if all the elements in A do not have a corresponding value in B, as we see in this case, okay, then therefore it isn't a function. So this is not a function. Okay, so B doesn't have to be mapped onto every element in A, but A needs to be connected to every element in B. Okay, so 2 elements in A can be mapped. Another thing to note about functions here now is that 2 elements in A can be mapped onto the same element in B. What this means is that if we use 3, it'll give you the letter C, and 4 could also give you the letter C, and this is correct. This is still a function. Okay, this is a function. All right. The next note now here is that one element in E cannot be mapped onto two elements in B, meaning that if I have if I have 3 in the set A and C and D in set B, this is not a function. Okay, because an element in E cannot be connected to two elements in B, right? If it is, then that is not a function. To determine, so again, remember I said let set A be X and let B be Y, okay? And if you want to test if something is a function, we have a test called the vertical line test, okay? And the first step you have to do for the vertical line test is to simply draw a graph of the function, okay? Draw a graph of the function. And if you could draw a vertical line which crosses the graph at more than one place, it is not a function. Because think about it, right? If we have a graph here, right? And let's say it cuts it in more than one place, right? What this would mean is that this one particular x value would have 3 corresponding y values, okay? This element in set E would have 3 corresponding values in set B, and notice that we just now said here that that cannot happen, okay? 2 elements in E could give you the same element in B, but one element in E cannot give you 2 elements in B. Okay, that's the difference, okay? So this is a easy way to remember it. One x value cannot give you multiple y values, okay? So let's look at the examples here and determine whether they are functions or not. So we have the graphs here, okay? Let's say now here we draw a vertical line. If we draw a vertical line at anywhere here, it only cuts the graph once, okay? It never cuts more than one, therefore this is a function, okay? This is a function. This one here now, so okay, so the first one actually is the graph of x squared. Okay, if you draw the graph, this is actually the graph of x squared. Sorry for my bad graph. Okay, but this is the graph of x squared actually. This one here now is the graph of the square root of x, okay? If we draw the graph of the square root of x, we would get this. Because remember, if I want to find the square root of 4, this could be equal to plus or minus 2. Remember, the square root of 4 could be a positive number or a negative number, which is why we get this graph. Now, if we draw a vertical line here now, notice that this cuts the graph in 2 places, therefore it is not a function. Okay? This next one here now is the graph of y is equal to x. Okay? Y is equal to x, and again, if we draw a line here, it only cuts at one point, so it is a function. Is a function. Okay? Circles now. Notice we have the circle. A circle, you remember the equation of a circle is x squared plus y squared is equal to r squared. And again, if we draw a line here, it cuts the circle in 2 points. If anytime we draw a vertical line, it will cut the graph at 2 points. Therefore, this is not a function. Okay, so that's pretty simple. Just remember, to test if something is a function, we're using the vertical line test. Okay, and remember, in terms of x and y values, one x value cannot give you multiple y values, but multiple x values could give you one y value, and that's okay. Okay, um and again here, remember, every element in set A must be mapped on to another element in set B. Okay, notice the difference between the codomain and the range. The range is a subset of the codomain, and to be part of the range, you need to be mapped on to by an element from set A. Okay, and this is basically it for the video on functions. It's pretty simple. The best way to do these questions is through examples. So look forward to the next few videos where we'll continue the topic of functions. Okay, This topic of functions is divided into 3 videos. So look forward to the next video. Thank you for watching. Goodbye.